open one simple model, very simple model, just to explain you all this concept. So if I open this file, you can see that the list will appear. What type of file you want to open? Ansa file, IGS file, step file, UDFS file. So these are the standard format that you can export in this format from any CAD software. All the CAD software are capable of exporting the CAD model in this format. Generally we prefer step file or IGS file if it's not the Ansa file. So here in this case I will open a step file, let's say topology definition step file. The same file with Ansa name is also available. You can use any of them, both are same. So I have opened my very first file with this name called as topology definition file. Now here you can see that as soon as I import the model, you can see different things. So what I was explaining is that as soon as you import the model, it could be possible that you are able to view this in this format, or you can see this curves first. So if this is the view, what you need to do is first you can click on the shadow, and once you click on that shadow button, now you will be able to see that all the surfaces and all the faces of the model. So one thing that you need to observe is that as soon as you import the model or open the model, you can see now this model has this model has different colors. So what color I can observe is that there are red boundaries, there are yellow edges, as well as there are some blue cyan color edges, not blue but cyan. So in this manner, this is the first observation that I would like to bring some attention there. And this has some purpose. These are there just not like for a different color and good graphics or something like that. These are purposefully there to indicate you and gives you some information. What exactly this information? That is what we are trying to look right now. Now, throughout the training period, we will call something as cones. So this cones means what you are watching right now is single cones, it could be double cones, or it could be triple cones. So basically cones is a surface which are separately there. For example, there is a cones here. If I say info and if I click on this, you can see these cones information are available. So these are each cones. These are each, you can click on each edge and you can find. So this each cones value you can find it over here. Not value, but other than each cone, you can see each edge is one of the cone. Now what you need to understand is that information is not important. Important is that you understand the color and the meaning of the color. So let's go back to first. If I click on the shadow, what you can see right now is that, let me walk on this. Okay, I will as of now delete this surface. Okay, so right now you can see that there are two faces, and these two faces are sharing this edge as a common edge. Now if I move this face, okay, by let's say a distance of 0.02 in minus x direction. What I'm trying to move is, I'm trying to move this surface in minus x direction 0.02. What you can see or observe is now there is no yellow edge. Now you can see there is a gap between these two surfaces. Can you see this? Now you can see there is a gap between these two surfaces, and this gap is exactly of the distance 0.02, which I have moved right now. So now you can see that now these are two independent faces not sharing any edge, and that is why each face has single cones as their outer boundaries. There is no double cones as of now. Now, if I connect these two faces at this junction or at this edge, then my single cones at this location will be converted into double cones, because two single cones are now being pasted, or that will be pasted together. So that is why the single cones will be converted into the double cones. Let me paste that. Okay. So what I will do is, I am trying to paste. Don't worry about the feature I am using right now. Just try to understand the concept. Okay. Don't worry about the feature I use. So I am trying to paste these two. Now you can see that instead of red, now you can observe this yellow line, which were earlier two red lines. So now you understand that if any edge is shared with, if any edge of any face is shared with any edge of the other face, then that particular shared edge will become, in yellow color, will become double cones. But if any edge, for example this edge, this edge, this edge, or on three edges on this side are not shared with any other face, that is why you can find them in red color, because they are independent, they are free, they are red edges. So that is single cones. But here at this location, that will be called as a double cones. So let's try to understand in our next model, or let's say in the another geometry. Now you can justify that why there is a yellow line at this junction, because you can imagine that this is the common edge between these two faces, and hence you can find this edge in double cones in yellow color. But again, the remaining outer boundaries are not shared or connected to other boundaries. That is why it is in red color, which are single cones. Again, in this case even, you can see this, the outer boundaries are in red, and even the hole in the model, will be, its outer boundaries of the hole will be in red color, which are again free edge. So what you can observe, that all the free edges which are not shared with any other face will appear in red color, and that is what we will call as a single cone. Any edges which is shared by the neighboring face will appear in yellow color, and that we will call as a double cones. Now again, going back to the next one and this model, here you can see that all the faces are connected with each other. So let me just make it visible only these entities. So now you can see that all the faces are connected with each other. This is a block, square block with a hole. So you can see that now there are no red boundaries in this model. There are no red boundaries in the model. So all you can see are just yellow double cones. There are no single cones in this object. And why? Because everywhere all the edges are connected with some edges. So for example, in this case, this edge is shared by these two round surfaces inside of this hole. The same way, this edge is shared by these two. This edge, this vertical edge is shared by these two, and so on. Now, why there is no red boundaries for this circle, which was the case earlier? Because now this top face and bottom face are, or the vertical and these two face are connected to each other. For example, if I click on this face, so what I am trying to say is, so this face and this face are connected to each other. So now there are again two faces. You can see that the reason behind having this in double cones is that because the top face is the one face and the circular pattern is the second face, and these two faces are sharing this edge, and hence this portion or this much portion appears into the yellow because it is the common edge between these two faces. The same manner it will go ahead for all these edges. So now you should be able to understand why there is yellow edges, why there is red edges in this model. Now let's understand the third one, that what we call as a triple cones. So I will bring my surface back which I have removed. And so what you can see right now is that there are two colors. One is yellow and one is red. Why? Because the yellow is from the bottom face which are connected to each other, but this bottom face is right now not connected to this vertical face. So there are two separate face. The one is the club together the bottom face, and this vertical face is the another one, but they are not connected together right now. They are separate. You can see there is a gap. You can see there is a gap. So now what I will do is I will paste them together. I will combine all these three such that this edge will become the common edge between three faces. I am trying to make this edge as a common edge between three faces. One face on the left side, horizontal, one face is the vertical, and the third face is the horizontal again on the right side. So let me do that. And as soon as I did that, now you can see that color has changed for this edge, and now it is in cyan color. So why? The reason is again because now this edge is a common edge between three surfaces. This edge is a common edge between three surfaces, and now I will call these cones as a triple cones because this cones is shared by three faces. So now you can imagine that there will be no triple cones in this model because there are always two surfaces connected, one and two, or you can say this and this. So each edge is sharing only two surfaces in this model. Now here the case was that there are three faces sharing the same edge, and hence it becomes the cyan edge as a triple cone. So this is the concept that I would like to explain, and I hope now it is clear what means single cones. Single cones means free edges, edges which is not shared by any faces. Edges which is not shared by any faces will remain in the red color, will be called as a single cones or free edges. Now comes to the double cones, edges which are shared by any other surface, or edges which are shared by just two faces, not more than two, will be called as a double cones and will appear into the yellow color. While the edges which are shared by three faces, the edges which is shared by three edges will be called as a triple cones, and it will have the cyan color. So now this point is clear what it means by single cones, what it means by double cones, and what is meant by triple cones. So again, going back to this option here in the bottom right side, cross hash, what will happen is that it will show you the cross hashing in the face for each face. So each face will have this cross hash which will help you to identify how many faces are sharing. So if you now observe this model, you can see there is one cross hash pattern of green for this face. So there is this, we will call as a face 1. There is second for this vertical face, and there is third for this face. So now you understand that yes, these 3 faces are being shared at this location. While in case of this model, you can see that there are always 2 faces connected. There will be no third face meeting. And here again the same way you can identify that these 2 surfaces, horizontal and vertical, are being connected by this common edge, and hence this edge will appear in yellow color, which we call as a double cones. So please understand this concept. This is very important. Whole concept is of the topology is based on this terminology of topology. I will deactivate the cross hatch. So now you can observe all the hot points. So this is what we call as a hot point. You can see that in this pink color over here. These all are our hot points. This will be at the end of the another, so on the face, on the edge, and you can find it over here, here, everywhere. You can find this. So these are the hot points. Now, if we have any curves or points in the model, as I said, you can see that now if I activate the points, you can find out the points which are available in the model in this cyan color. So these are the points in the model which may be created just for reference or for creating the surface. And another thing that you can activate or deactivate from this flag button is you can find the button single. So the single cones can be activated or deactivated, or let's say show or hide, using this button. Same way, this double cones can be activated or show or hide using this button flag button over here. And the same way you can do this for triple cones. You can hide or show triple cones. But I will recommend to make sure these all 3 are activated always, because otherwise it may lead to the misconcept or something. You are trying to create the surface, but you are not able to watch this surface because the double cones is not activated. So in this manner, you have to keep these 3 always activated. Now let me deactivate this double and singles. So now I can show you the curves. What you can see is these are our curves. One is the circular and the another one is the plate. These are curves and the points in cyan color. I am just making them show or hide just to exactly identify. The same way you can activate or deactivate curves. You can make them visible or you can hide them. Okay, but generally once we finish with the work or whatever the intention was to create the curve, we deactivate them. Okay, so now you have understood what it means by single cones, what it means by double cones, what it means by triple cones, as well as the color for points as well as curves. So we have understood this point. Then next will be surface. Weld spots we will see later on when we go for the welding. It would be in yellow color as a double cones. For example, I say that okay, when I imported this file, it says that it is giving me like this when I import the model. So then as soon as I import this model, I have to decide now, after observing this part in wireframe mode or in shadow mode, I have to decide that okay, what I see is here that I can see there are 2 faces sharing this edge. So it now gives me hint why there is red line, why it is not giving me double cones, because if it is sharing the common edge, now I know that this line should appear in yellow. So we will see that if it is not red, what are the features can be used to convert it into the red, like I did right now. So now I am satisfied with my skill. Now I am satisfied with this model, that yes, I can understand why there is double cone there, because it is a common edge between these two faces, and now I am satisfied with my model, with my operation, that yes, now this model is fine. This outer boundary should be in red because it's a free edges. The same is true for this face and the circle. The only question was, I was earlier were able to see the red lines, which I was not very happy with that, because it should be in double cones, as it is sharing the, as two faces are sharing the same edge. So I did the I performed some operation and converted it to the double cones. So in this manner we will see what can be done in order to check that single cones are right, double cones are right, triple cones are right, and so on. And after that, this is my closed body volume. So you can see that this is a closed body volume because there is no open faces. Yeah, so it's like a solid. So in this case, the rule of thumb says that all the edges should be double cones, because if it's a closed body, then there will be always one face will be connected by the neighboring face. Then only it can become a closed body volume or a solid. So now my rule of thumb will help me if I would able to see any red edges over here. So right now all the edges are in yellow, which are double cones. So I can justify that whatever I can see is true. If it's a closed body volume, I should be able to see all the edges in yellow. If it is not the case, let's try to do again something same way, just to show you that if I say, okay, translate this by 0.01, or it's not, it's 5.02 distance. Sorry, it's 1, and here is the distance 0.01. Okay, so, or if I move this surface into the Z direction, I will move it by the distance of 0.01 into the Z positive direction. So now in this manner we can identify if it was a closed body volume, then as I said, it should appear in this same color. For example, if I do this topo, now can you justify why I can see this face in cyan color? Because it is very much clear that there are no three faces. Here if you see, this top surface and this face are shared by this edge. So I expect this is in double cones. The same way these two side faces are shared by this edge. So again I expect it in this yellow color, and the same is true for this side. Now what happened is that I have copied the surface. That means if I translate and move this face into the direction of Z by distance 2, what you can see is that now I have moved this surface, and if I say delete this surface, now you can see that I can, if I remove this surface, I have already removed the surface. Okay, so if I say undelete, you can find the surface there. So what happens is that because of the duplication of the surface, I was able to watch their three surfaces. Now if I again move it back into the direction and with this distance 0.02, we'll say translate, move this surface into the z minus 0.02. So now we can think of connecting them back. So bring all, so translate, and we will move this face into the direction of minus z by the distance of 0.02. Okay, let me read the text message, what it says. So my text message will give me some hint. Okay, so it has moved my surface into the direction as I wanted. So now you can see that if this is a open block, then you can see this again, there are red boundaries in the block, and these red boundaries are now justifying because they are not connected. So if I create new surface, let's say between this and this, okay, same way for this, and the same way on this side. So I have created a new face, but still you can find that this edge is again appears in single cones, which should not be the case because it's a common edge between this face and this face. So I will perform some task to make sure it converts into the double cones. So now I hope you have understood that in this manner you can see that we can convert single into double cones and check out whether single, double and triple cones are correct in the model or not. So that was the main intention for in this particular lecture, where we want to discuss about single cones, double cones, triple cones and their understanding. Now what you will do is, as a self-practice